Alright, Marvin Blake here, and so this time I just had a previous video explaining the whole system, and now I'm just gonna go through the code on TA portal for the main functions without the online elements. So as you can see right now, I've gone online, and I can look through the code in real time. You can see the clock bits moving, and all the rings going in and out, and cycling through. So I ended up using 13 networks on the main operation block. So this code here has a sensor that stops the conveyor belt, and the conveyor belt is on, and this one does the light, and the other one does the conveyor itself. So if I turn on the conveyor system, then you can see the whole run becomes true. So the one that's ticking according to the clock bit, that's for the signal light, and the solid state is for the motor. You can see. And if the motor hits the product hits a sensor, the line stops. So the next code is pretty much if the sensor is received, then the value of process goes up. So you can see that the HMI right now it's at 156, and then this one is for cells. So if the sensor on the cell side of the system, when an item is sold, that number will change, and then for inventory you just do the math between what you've created and what you've sold, and then it'll tell you how much is left in the system. Then the next network, this one is the one that initiates the web page to be able to use user-defined web pages on the Siemens PLC. Usually they want you to start on data block number 333. So that's what I did, and because Siemens, the 1200, the S7 1200 is a really strong system. Even way before people were looking for IoT, it had its own inbuilt server, and they had this function block here to help you be able to use that, because the AWP, the automation web programming, converts any HTML web page with CSS and JavaScript through this data block turns all those into ones and zeros as usual, and it'll build from data block 333 all the way down. So depending on how long your code is, the more data blocks you'll generate. So this one is for creating data log, because I wanted to be able to have a data log system that can turn directly into an Excel spreadsheet. So I'll walk you down. So the records, you set the number of records you want to have for each Excel spreadsheet. So if the more you have, the longer the more rows you'll have on your Excel spreadsheet. And then the name of the file that's going to be created, and then the data of the table, and then the header. This is the titles of which the columns, the names of the columns. So we have the process, the inventory, and the sales, and then the other ones for the done bit, busy bits, error bits, and the status. You can all use this to diagnose if any problems are going in with your data logs. And then you always have to pair the data log with the data write. And here I use a clock bit of 2.5 hertz to keep on. This is how often it'll run this iteration, so you get the records that way over and over. But you can change this into a timer on or timer off delay. I mean a timer on delay, and then you can set it to however frequently you want. If you want your data to be collected once a day, once every 4 hours, once a month, this is what you need to mess with the requests for data log. And then so the data log is created depending on the input here. So you can here I tied it up to a button. Oh no, I actually did it on the HMI. But you can use any other input or another event to initiate the request for the creating a data log. And then once that done bit is on, when the done bit for the data log is done, then this will ring true and it'll set. And this tag 1 is what you use to do the done bits. So the next network is about processing the data. So the process data, it's being done at 2.5 hertz. So you can always see what's currently the data value. So we want to move the process number, and then we move that into the data logs. So that's why we are doing that. We take the data that's here and we move it into the data log, and that way you can be able to use it. Same, so we did a move for the process data, a move for the cells, and a move for the inventory. And then finally we have the cylinder, which extends and retracts according to HMI inputs. So one input extends when you hit it, it'll extend and reset the retract function, and then it'll count for 5 seconds and do the reverse, and then the timer for the magnet is on 7 seconds. So the magnet stays on for 7 seconds, so you'll pick up the product, come back, and then it'll drop it. And this one is the reverse of it. So you have the extend and the retract. So when this one finishes, it'll initiate this one, and it's mainly for the functionality of the networks. So next video I will show how the data blocks and the web data blocks work.